Microcontrollers and its application, presented by G. Ramachandran. Microprocessor was invented in 1960s. It was designed with logic gates. Intel introduced a 4-bit microprocessor 4004 in 1971. 8-bit microprocessor is 8080. Another one is an 8-bit microprocessor is 8085, which contains 8-bit data bus plus 16-bit address bus. A 16-bit 8086 contains 16-bit data bus plus a 20-bit address bus. Examples of 16-bit processors are 8088, 80186, 80188, 80286. Examples of 32-bit processors are 80386, 80486, 80586. What do you mean by a microprocessor? The word comes from the combination of micro and processor. Processor means a device that processes whatever it gets. In this context, processor means a device that processes numbers, specifically binary numbers, zeros and ones. To process means to manipulate. It is a general term that describes all manipulation. Again, in this content, it means to perform certain operations on the numbers that depend on the microprocessor's design. The microprocessor is a programmable device that takes in numbers, perform on them arithmetic or logic operation according to the program stored in memory, and then produce other numbers as a result. What is a microcontroller? It is a large scale integration to very large scale integration. It is called microcontroller. To build microprocessor, what are the uses of microcontroller? To build microprocessor, memory and input-output device on a single chip. Components of microcontroller are microprocessor, analog to digital converter, digital to analog converter, parallel input-output interface, serial input-output interface, timers and counters. 8085 microprocessor. 8085 is a 8-bit microprocessor designed by Intel, and it was introduced in 1977 with NMOS technology. It has the following configuration. It has an 8-bit data bus, 16-bit address bus, which can address up to 64 KB, a 16-bit program counter, a 16-bit stack pointer, 6 8-bit registers arranged in pairs. The memory locations are from through A0 to A15. The first 8 lines of address bus and 8 lines of data bus are multiplexed AD0 to AD7. Data bus is a group of 8 lines D0 to D7. It supports external interrupt request. A 16-bit program counter is present. The architecture of 8085 is as shown in the figure. As shown in figure, it consists of accumulator. Accumulator, it is an 8-bit register used to perform arithmetic, logical, input, output and load store operation. It is connected to internal data bus and ALU, arithmetic logic unit. As the name suggests, it performs arithmetic and logical operation like addition, subtraction, and or etc. on 8-bit data. General purpose registers. There are 6 general purpose registers in 8085 processor, that is B, C, D, E, H and L. Each register can hold 8-bit data. These registers can work in pair to hold 16-bit data and their pairing combination is like B, C combined, D, E combined, H, L. Program counter. It is a 16-bit register used to store the memory address location of the next instruction to be executed. Microprocessors increments the program whatever an instruction is being executed so that the program counter points to the memory address of the next instruction that is going to be executed. Stack pointer. It is also a 16-bit register, works like stack, which is always incremented or decremented by 2 during a push and pop operation. Flag register. It is an 8-bit register having 5 1-bit flip-flop which holds either 0 or 1 depending upon the result stored during the accumulator. Instruction register and decoder. It is an 8-bit register. When an instruction is fetched from memory, then it is stored in the instruction register. Instruction decoder decodes the information present in the instruction register. Timing and control unit. It provides timing and control signal to the microprocessor to perform operations. Following are the timing and control signals which control external and internal circuits. Control signals, for example, ready, read, write, etc. Status signal, S0, S1, input, output, etc. DMA signals as what hold, HLDA, reset signals are present. Interrupt control. As the name suggests, it controls the interrupts during the process. When a microprocessor is executing a main program and whenever an interrupt occurs, the microprocessor shifts the control from the main program to process the incoming request. After the request is completed, the control goes back to the main program. There are mainly 5 interrupt signals in 8085: INTR, RST, RST 6.5, RST 5.5, TRAP. Serial input-output control. It controls the serial data connection by using these two instructions, namely serial input-output data and serial output data. Address and data bus. Data bus carries the data to be stored. It is bidirectional, whereas address bus carries the location to where it should be stored, and it is unidirectional. It is used to transfer the data and address input-output devices. Flag register and GPR of general purpose registers of 8085 is shown in the figure. It consists of an accumulator, sign, the flag register consists of sign, flip-flop, 0, auxiliary carry, parity carry, etc. The general purpose registers are B, C, D, H and L. Instruction set. 8085 instruction set consists of following instruction: data moving instruction, arithmetic add such as add, subtract, increment and decrement, logic and or XOR and rotate, control transfer, conditional, unconditional, call subroutine, return from subroutine and restarts, input output instructions, others, setting or clearing flag bits, enabling or disabling interrupts, stack operation, etc.